Hello, my name is Shamini Dilshika. My student ID is 2021-0481. My supervisor's name is Mr. Manu Singh. Today I am presenting my project titled Offline First Learning System for Rural Education. This project focuses on providing personalized and accessible digital learning for students in low resource and low connectivity environments. Despite the growth of digital education, rural learners continue to face significant barriers in accessing e-learning platforms. The first issue is the infrastructure gap. Rural students experience what is described as nomadic connectivity, where internet access is only available at specific times or locations, making continuous learning impossible. The second issue is a critical system failure in existing platforms. Most learning management systems such as Moodle and eTaxalaver are designed with an online first approach. When connectivity is lost, student progress is often disturbed or not properly saved. The third issue is the cognitive barrier. Many systems are designed primarily in English, which increases cognitive load for Sinhala medium learners. According to Don Norman, complex interfaces and unfamiliar language significantly reduce usability and learning effectiveness. These combined challenges create a significant digital divide, preventing rural students from effectively engaging with modern e-learning systems. While reviewing existing adaptive learning systems, I observed that most platforms fail to address the specific needs of rural students. The gap can be summarized in three key points. Connectivity limitation. Most systems require continuous internet access, making them unsuitable for rural students with poor or unstable connectivity. Limited localization. Existing platforms are mostly in English and lack bilingual or culturally adapted content, creating barrier for beginner learners. Weak personalization. Adaptive learning features are either missing or superficial. Content is rarely tailored to individual student performance or engagement levels. These limitations prevent rural students from accessing high quality digital learning and reduce engagement, creating a significant education divide. My project addresses this gap by designing an offline first bilingual adaptive learning system that integrates personalization, gamification, and teacher driven content management. The primary goal of this project is to build a resilient learning framework that ensures continuity regardless of internet connection status. I achieve this through three core pillars: reliability. All student progress, quiz results, and learning materials are safely stored offline and synchronized automatically once online. The ensures no data is lost even in low connectivity environments. Equity. The system provides bilingual content in English and Sinhala, making learning accessible to all students regardless of their preferred language. In flexibility, teachers can upload materials, create quizzes, and monitor their upload history via both a web portal and Android app, giving them flexible options to manage content. Together, these pillars create a robust system that supports offline first learning, personalized adaptation, and teacher student asynchronous integration. As shown in the diagram, the architecture follows a layered approach to separate responsibilities and ensure smooth offline and online interaction. The student app is designed for work primarily offline. It stored learning content, quizzes, and activity logs locally using SQLite or shared preferences. In client tier, it shows the uh, students and teachers with their mobile and web app. The mobile app learning app for students, teachers for the mobile and web app. In offline data tier, SQLite and share preferences stores offline activities, quiz results, progress logs, and accepted contents are uploaded uh, to the system from backend tier. Uh, the contents are accepted by admin, and admin is the person that uh, materials are upload to the system. In offline activities also uh, saved in SQLite after the uh, internet connection is available, it's automatically synchronized to the backend. Firebase Firestore act as a backend, and Firebase authentication is for um, teachers to user to secure their user authentication. And also in backend tier, adaptive engine gamification modules such as points, badges, levels, and analytics and monitoring, student progress dashboard, and um, Firebase authenticant in backend tier, and also external services and API tier, the Firebase Firestore and Firebase authentication act to the Firebase Firestore approve content signing and Firebase authentication secure user authentication. In technology stack, in presentation layer for the mobile app and teacher portal. In application layer, quiz logic, offline signing, badge logic, which is badge logic means badges that generate based on students' marks. And in data layer, SQLite, shared preferences for store, quiz, and quiz progress, student progress, JSON files for generate quizzes. Signing layer is for when offline data is syncing after the internet is available. The testing and evaluation focused on four key metrics: functionality, offline reliability, user satisfaction, and critical expert evaluation. All system failures features, including lesson access, quizzes, and exam papers, function correctly. Offline testing confirmed that students can learn uninterrupted with data syncing uh, automatically once connectivity is restored. User feedback showed high satisfaction, uh, especially with bilingual support and gamification, while expert review highlighted the intuitive design and educational effectiveness. Mine recommendations focused on scalability and adaptive algorithm improvements. Overall, the system reliably supports offline learning and effective engagement for students and teachers alike. During the evaluation phase, the system was assessed against reliability, effectiveness and usability criteria. Key outcomes are reliability in low connectivity. The system consistently functions offline, storing data locally and synchronizing automatically when device is online. This ensures that students is in rural areas can access learning materials without interruption. Adaptive recommendations improve learning. The adaptive learning modules combined with gamification quizzes and reflection prompts successfully tailored learning paths to individual students' performance, enhancing engagement and comprehensive. In bilingual support, effective because the students could switch uh, seamlessly between Sinhala and English. Feedback indicated that bilingual content increased understanding and accessibility for learners at different proficiency levels. Overall, these outcomes demonstrate that the system achieves its main objectives of providing reliable, adaptive, and inclusive learning in low-resource environments. In novelty and contribution, this project introduces a first-in-market innovation for the Sri Lankan curriculum, which called the hybrid sync model. This model uniquely combines offline-first learning on the student side with online content management on the teacher side, ensuring learning can continue uninterrupted even in low connectivity environments. From a contribution perspective, the system establishes a validate architectural pattern for delivering educational equality in disconnected context. This pattern can serve as a reference for future systems aiming to bridge the digital divide in rural education. This system not only addresses current accessibility challenges but also provides a replicable framework for inclusive learning in similar environments. While the system achieves offline-first learning effectively, there are some limitations. First, synchronizing the entire application, especially with large datasets, can be slow on low-end devices. Second, device storage constraint may limit the amount of offline content a student can carry. In future work, to address these limitations, optimize synchronization algorithms to speed up full app updates, implement student performance tracking for teachers to monitor learning progress, expand cloud storage to accommodate larger datasets, and support for Tamil language, making the system accessible to more students. These enhancements aim to improve scalability, performance, and inclusivity of the system. During this project, I acquired several new technical skills and also strengthened existing skills that were crucial for completing the system. Flutter development, which I used to build the cross-platform mobile application for students, offline data management enabling the system to work reliable even without internet connectivity, file-based storage integration which allowed me to synchronize students and upload teacher materials efficiently, and the application of human computer interaction principles ensuring that interface is intuitive and accessible for students of all levels are new skills I developed. Existing skills that were enhanced are software design, where I refined architectural decisions for both mobile and web. Testing and evaluation apply systematic methods to verify functionality, usability, and offline performance, and data synchronization techniques which are essential for ensuring consistency between students' device and the online teacher portal. These skills collectively allowed me to build a robust, user-friendly, and scalable learning platform, and they will be directly applicable to future projects in software development and educational technologies. In conclusion, this project successfully addressed the challenges faced by rural students in accessing digital learning resources. By developing an offline-first adaptive learning system, I ensured that students can learn anytime, anywhere, even with limited internet connectivity. Throughout this project, I not only applied existing skills, software design, testing, and evaluation, but also acquired new skills like Flutter, offline data management. Ultimately, this system bridges the gap between rural students and modern digital education, providing scalable foundation for future improvements and innovation in educational technology. Thank you.